Hello Team 613. I'd like to talk to you a little bit about the second step that we have in programming our cRio. We talked in the last presentation about how it's necessary to hook up all the hardware components so that they communicate with each other, and we talked a little bit about IP addresses and how to set that up. The second step with our hardware is preparing the cRio to receive the program that we send to it and to execute our software correctly. So this is called imaging the cRio, and in this presentation I hope to show you the steps that you would need to go through to correctly image the cRio. If you remember, this is our robot right here. This is our cRio. I don't know exactly why it's called a cRio, but it's the computer that they gave us to use with the robot. And I'd like you to think about, well, what are the parts of a computer? This is probably something that you have discussed before in a science class. So think of all the parts of a computer that you can come up with. All right, well, if we look at our cRio here, you know that a computer has a processor. It's basically a fancy adding machine. It has some memory stored in it, like any computer. That memory is divided into the hard drive. Hard drive can store a lot of memory. Something called RAM, which is just another type of memory, and cache, which is another type of memory that's very, very fast, so you can store information and take information out of it very, very quickly. So there's definitely some memory inside your computer. And then the cRio, if we look at it closely, it's got some electrical cords coming out of it and some electrical cords plugged into it. And in fact, it's not plugged in the picture, but there's this other cord that goes back to our router. That you might have remember from our electrical presentation. And so a computer also has a lot of electrical inputs and outputs, and our cRio is going to send and receive electrical signals from the driver station. It's going to send signals to our motor controller through this ribbon cable, and it's going to receive a signal through these cords right here from our power distribution board, and that's going to be used to measure the voltage of the battery. So our computer has quite a bit of hardware pieces to it. A processor, it has some memory stored inside of it, and it's also got these electrical input and output devices. Now, we know that these are the parts of our computer. We know that we put a program and we store it in our memory, and our program basically has a series of instructions that are used to run the processor, manipulate things that are stored in memory, and then send and receive signals from the electrical output. Now, we could, if we wanted to, include in our program all the directions that are needed to manipulate all the electrical signals that go to our processor. We could tell in our program all the instructions that are needed to have the hard drive reader go to the exact part of the hard drive where the information is that we need, learn how to read the zeros and ones off of that hard drive and interpret those zeros and ones. And we could include in our program all the directions that are needed to send and receive electrical signals. It'd be a big program. It would be kind of complicated to write, but it would be possible. However, what would happen then is that if we do our program and we include all those instructions, we'd have to do it again if we wrote a second program and a third program, and so it'd be a little wasteful. So in fact, what computer scientists do is they have something called another layer that's called drivers and operating system. And what this is a little piece of well, not a little, but a piece of software that is in charge of talking to the processor directly to the memory, the electrical input signals and the electrical output signals. And so it knows how to communicate with these, how to send the correct signals to the processor, how to access certain parts of the memory and interpret the zeros and ones that come back from the memory. It knows how to send electrical input signals or receive electrical input signals and interpret them and whatnot. So this is all done once, and then our program communicates not directly with the processor but with the output from our drivers and the operating system. This is not a robot driver. This is a software or hardware driver, rather. So you don't want to confuse that. But so, for example, our program doesn't need to know specifically all these kind of in-depth details. It just needs to be able to ask the drivers, oh, can you tell me what the value of this piece of memory is? And then this takes care of all the low level of all the details and sends our information back to our program. This is really nice when you think about there are quite a few advantages to this, but one advantage is that it simplifies our program. We don't need to do all that itsy bitsy coding in our program. Also, if we have multiple programs on our computer, we only have to have this information and these instructions written once, and all the programs will use the same set of instructions. And then finally, probably the most interesting thing is that on our computer, we actually have two different cRios that are two different versions. And those two cRios might have a slightly different processor. Well, they do, in fact. They might have different memory, and the way the electrical signal input and output are interpreted by the cRio might be different. What is done is the driver knows how to communicate with both of those processors, both of those memories, and so this is modified to deal with our two different cRios. But we don't need to change our program at all, because this interface between our program and the drivers and operating system doesn't change at all. And so this really simplifies things, because then we don't need to write a specific program for one computer and a different program for another computer. Think about it this way as well. One person, you may be running a computer at home that has a Pentium chip, or, well, not a Pentium chip, that's kind of old, but one type of computer chip, and someone else may have a computer with a different type of computer chip in it. Now, if it wasn't for the operating system and the drivers on those two computers, you would have to have a different version of the program. Let's say a different version of Microsoft Word for your computer and a different version of Microsoft Word for that other computer. But because of what Windows does is it adds a layer in between the processor and your program, and Windows takes care of dealing with those differences between the processors, and then it provides the same language for you to communicate back and forth with that Microsoft Word. So it makes it so you only need one version of Word, and it can run on both of those different pieces of hardware. Okay. Anyway, the whole point of that is that what you really just need to know is that this is a really important part of our cRio, these drivers and operating systems, and this is what you do when you install this and put this onto the cRio when you go through this imaging step. So let me show you how we do that. So this is our driver computer on the desktop. There's a tool, there's a link here, you just double click on it. It's called the FRC 2014 cRio imaging tool. What it's going to do is it's going to take a copy of the drivers and the operating system for our cRio, and it's going to copy it from our driver station computer onto the cRio, and that's called imaging, because you take an image of what we have on our computer and you copy a direct copy of the image onto the cRio. And so once you double click on that, it pops open this dialog box, and what it's going to do is going to search to see if we're connected to our cRio. It's going to tell you the name of the cRio, the IP of the address of the cRio, which should be 10.6.13.2, as we know from the last presentation, and then it's going to tell you the version of the image that currently is on it. Now, what you may notice is that this may be, let's say, version 54, I think we're up to. Down here, it lists the images that are currently available on our computer. And if you ever see, let's say this says version 54, and you see something a little bit higher here, it means that there's a new version of the image of these operating system and drivers that is available, and we're going to want to send it over to the cRio so it has the most up-to-date operating system on it. So what what happens is the reason this gets updated is that we've set up NetBeans so that it will automatically check the web for an updated image and download it to a special file every time it's available. And then right here, it just lists all the images that are available. So it's all done automatically, which is convenient. And it's a nice way to, it's a nice way that first makes certain that you're getting kind of the most up-to-date drivers and operating system for your computer. Now, you can imagine that if you're going to image your cRio, so you're going to send this driver over to the cRio, you pretty much wipe out all the memory that's on the cRio, and then you copy this image directly onto it. And so any program we had on there before is going to get deleted, and it's just going to create an identical version of what's in this file. Okay, so that right there is going to tell you your image. And then right here you have some different tools you can select. We need to make certain that we download some extra software that helps with our Java program, and so you're going to select Java Technology. Whoops, hold on a second there. So we're going to select Java Technology, and then if we need to format the controller and send over the new image, we're going to check this box, and then we're going to select the most up-to-date image. The device name is going to stay cRio or whatever it currently is, and it should remember that our team ID number is 613. This is used to set the correct IP address for the cRio, because we're pretty much wiping all this memory out when we put this image on, so we need to keep the IP address up to date. And then you're just going to hit apply, and a dialog box is going to go up, and it's going to talk about how it's copying everything over. Once it's done, you need to reboot the cRio on the computer, so shut it off and then turn it back on, and then you've got your new image on the computer. So you've got all those drivers that are needed to have your software communicate with the processor on the cRio, the hardware, the I/O, and you've also got the extra bit of software that we need for our Java program to work. Okay, all right. So we talked real quick. We talked about, just as a review, the parts of the computer, all the different parts of the hardware that we have, and how it's simpler to have our program communicate with this hardware, not by directly talking to it, but by talking through this something called a driver and drivers and operating systems. There's a kind of a lot of nice advantages to using a driver and an operating system as opposed to having our program communicate directly to each of these hardware components. And then we talked about the tool that we would use to do that, which is the cRio 2014 or the FRC 2014 cRio imaging tool, which will tell us the current version of the driver and operating system that we have on the cRio. It gives us some options to download the Java technology that we want, and it gives us the opportunity to send the most up-to-date image over to the cRio. So this is an important step in preparing our cRio for competition. Okay, thanks very much.